Now, before we continue with adjusting our app to different device sizes, and we, for example, work on this modal and how it looks like in landscape mode, there's one thing I want to take a closer look at. And that would be widget size constraints, or specifically the issue we had before with the chart not working inside of a row. I want to make sure that you really understand what exactly the problem was with that and why we need expanded here. And for that, it's really important to understand the concept of size constraints in Flutter and to understand how in general Flutter widgets get sized and displayed on the screen. Because it's important to understand that widgets actually get sized based on their size preferences and the size constraints applied by the parent widget. And to make this sentence a little bit less abstract, let's take a look at the column widget. This column widget has some preferences regarding the size it wants to occupy. It wants to take as much height as it can get, but it only needs as much width as defined by its largest child, so as defined by its children overall. But since the column in theory, of course, wants to take as much height as possible, it's important that the column widget is inside of a parent that restricts the height, because otherwise it would go outside of the screen boundaries, which is not the goal. That's why we, for example, have no problem if a column is used directly inside of a scaffold widget, so as a value for the body parameter of a scaffold widget, because the scaffold widget turns out to constrain the height and the width to the maximum device height or width. But every widget has different constraints for its child widgets, so this is just an example here. But for this example, since we have the column inside of a scaffold with those constraints, the result would be that the maximum column height is actually the maximum device height, because that is the constraint by the parent widget, and the constraint of the parent widget overrides the preferences of the child widget. That's how sizing generally works in Flutter. And you can actually see this if you open the Flutter DevTools. Here I'm doing this in a browser. Now if we open this Flutter inspector, we can browse this widget tree and select different widgets there. And if we, for example, select this column, which is right below the scaffold, we can see that here on the right, we get this Layout Explorer. And this Layout Explorer, for example, tells us the height and the width that was assigned to this column widget, but it also tells us the constraints this column widget got from its parent, so in this case from the scaffold. And here, for example, we see that for the width, the constraint was that anything between 0 and the maximum device width is allowed. And for the height, it's the same, 0 and maximum height. And therefore, the column widget actually chose the maximum height and the maximum width, though the width simply depends on the child widgets inside of the column. Because as mentioned before, for the column widget, and actually for most Flutter widgets, the actual height or width that is taken depends on what the child widgets want. Though for the column widget, there is something special to be noted regarding the height constraints it passes down to its children, so to the chart, for example, which is inside of the column. We can see those constraints in here. Here we see that it's unconstrained vertically, so that the column widget does not pass any height constraints to its child widgets, so to the widgets that are passed to the column. And that, for example, would be a problem for the expenses list. Because this in the end renders a list view, which is also just a list and kind of a column therefore, and indeed the list view by default also would have no constraints. We don't see it here when we select the list view, but actually if we select the child inside of the list view, this dismissible widget, we can see that for the dismissible widget, its height is unconstrained. And since it is inside of the list view, that of course means that it's the list view that's not constraining the height for dismissible. So list view has an unconstrained height, as does column, and therefore list view would not be restricted in the height it tries to take up, and therefore it would of course go out of the boundaries of the device screen on which the app is running. because there simply is no height constraint. And that's exactly why you need this expanded wrapper here, because expanded does something special. If you add expanded, as we're doing it here around the list view in the end, expanded does set height constraints. It sets the maximum height of its child widgets, so of the list view in case of this expanded widget here, to the maximum available height. Instead of getting as much height as possible, so a height of infinity in the end, it takes as much height as it can get. And that's an important difference compared to an infinite amount of height, which is what column and list view would set as constraints. Expanded narrows that down and limits the available height to its child widget, so to the list view in case of this expanded widget here, to the actual available height. That's why wrapping unconstrained widgets with expanded makes sure that unconstrained widgets inside of other unconstrained widgets, as we have it here with list view inside of column, doesn't cause any problems anymore. And that's also the problem we fixed here with row and chart. Because chart actually does not render a row, but a container where I explicitly set the width to double infinity, to make sure that this container takes as much space as it can possibly get. But of course, that's a problem if we do this inside of a row, which also has a width of infinity. With expanded, as I just described, this is fixed because expanded between row and chart makes sure that chart is actually limited and can only take as much width as is actually available. And that's how widgets are sized and what size constraints are all about. This in the end explains why certain widgets can be used inside of other widgets without problems, and why, for example, a column inside of a column could cause a problem. But those problems then can be fixed, for example, by adding an expanded widget between the two columns.